Guys, in this example, I have a particle that has a mass of 0.5, and this particle is confined to move along this horizontal slope. So I know, guys, that this particle could only move in this horizontal slope, right? So it only has a rectilinear motion in this horizontal direction. I need to determine the force of the rod, this is the rod, on this particle, as well as the normal force of the slot on this particle. Now, the rod is rotating with a constant angular velocity. Theta dot is equal to 2 radians per second. So I know theta is 30. At this moment, theta is 30. And at this moment, theta dot is equal to 2 radians per second. In fact, at any moment, because this is a constant angular velocity. What does this mean? Theta dot is constant, means theta double dot is equal to 0, right? The acceleration, the angular acceleration is 0. I want to assume that the particle contacts along occurs along only at one side. So I'm gonna, guys, get back to this sentence at the end of this problem. All right, guys, if you take a look on this figure here, the particle at A is moving in this horizontal slope. I have a rod here, and this rod is doing a rotational motion. This rod has a certain R, a certain theta. I know theta dot, which means since I have theta dot, I have to apply the cylindrical coordinates, right? Not the tangential and normal acceleration, because I'm sure, guys, you're asking yourself how to know which reference should I use to solve these problems. Guys, it's very clear, all right? Because you're gonna have to analyze your given. Now here they are giving me theta dot. This means that I should use, of course, the cylindrical coordinates. In the previous example, they are giving me R, so I should use the cylindrical coordinates, and same goes here, all right? So let's go back to this problem. I know theta dot, and I also know this distance right here, which means, guys, I'm gonna use it. I'm gonna use this distance. Why? To find what, guys? What do you think? If I know this distance from this point to this point, and I know that this is theta and that this is R, all right? If I draw this triangle, this is R, this is theta, and this is 0.5. What does this mean, guys? Cosine theta will, of course, be equal to 0.5 over R. And this means, guys, that R is equal to 0.5 or 1 over 2 cosine theta. So now, guys, I know the equation of R in terms of theta. If I know the equation of R in terms of theta, I can find R dot. R dot would be dr over d theta times d theta over d time, which means times theta dot. And theta dot is given. All right? And if I know R dot, I can find R double dot. All right? So whenever, guys, I know R dot and I know R double dot, I can find what? I can find a R and a theta. And remember, guys, theta double dot is 0. All right? Theta double dot is 0. Let's put the reference, the cylindrical reference. This will be UR. And this will be U theta. There is no need here, guys, to find psi, because in fact I know this angle. This angle will help me, in fact, in finding the projection of components. We're going to see why. Now, what are the forces exerted on this ball here? I have, of course, the normal force exerted by the slot, and this normal force should always be perpendicular to the common line, all right? So the common line here is horizontal, then the normal force will be vertical. And the second force will be the force exerted by this rod here on the ball. Now, the common line is oblique, then the force exerted will be perpendicular to this common line, so this will be F. All right? And of course, I have the weight. So these are the forces exerted on this ball. All right? Now, I can apply sum of UR and sum of FR and sum of F theta. In fact, guys, because if I know this angle, if I know the angle theta, then I can find that this angle is equal to this theta, which means this is also 30 degrees. The angle between W and UR is equal to 30 degrees, which is also the same angle between N and UR. All right, so this is also theta. So there is no need to find xi here. Right? Now, if you find xi, it should be this one, this angle here. But there is no need to find xi because I know this angle. Right? This is because N is vertical. This is because N is not oblique, it's vertical. That's why. All right, guys? All right, guys? So now I can apply sum of FR is equal to MAR. All right? So sum of FR is equal to what? It is N cosine theta, and theta is 30, don't forget, minus W cosine theta is equal to MAR. MAR could be found by finding R dot and R double dot, because I know, in fact, theta dot and theta double dot, which is 0, as well as theta. Now, what is sum of F theta? Sum of F theta is equal to F. F has the same direction of U theta, minus N sine theta plus W sine theta. And this is also equal to MA theta. All right, guys? Now, if you do all of these equations, you're going to have that N is equal to 5.79 Newton, and F is equal to 1.78, which means they are both positive, which means that the direction specified at the beginning of this problem is correct, are correct. All right? Now, guys, if I want to go back to this sentence here, assume that the particle contacts only one side of the slope at any instance. As you can see, guys, there is a clearance here. So this particle, this ball, has not any contact with the upside, with the upward side of this horizontal slope. It has only this contact. What does this mean? In fact, guys, if this particle of this ball has two contacts, this means that I have two normal forces. An upward normal force caused by this one, by the downward side, and a downward normal force caused by the upward side. They are not equal, right? N1 and N2. But what you can do is, of course, you don't have to put N1 and N2. You can only put only one N, and this N here will be the net force between N1 and N2. All right? So this N will be the net force between N1 and N2. If N is negative, if N is positive, this means that yes, N is upward. If N is negative, this means that you should flip the direction of N, and this means, guys, that N2 is greater than N1. All right? And this is also applicable to the force caused by a road. For example, if you remember the first problem, the cylinder was inside the road. Although it is undergoing a curved path, but it is inside this road, which means also, guys, this road has two forces. One is downward and one is upward, all right? Now, whenever you indicate F, you mean by F the net force, all right? So you can indicate F as downward, let's say this is my F, and then if F is positive, this means that yes, F is downward and this force is greater than this one. This depends, in fact, on acceleration. Now, if F is negative, then this force will be greater than this force, and F should be the upward direction. Now, here in this problem, they are saying that the only contact occurs with what? With the downside the downward side, which means, guys, n should be upward. And this is why I found that n is positive whenever I assume it upward. All right? If you go back to these examples here, we found that n and f, they are both negative, which means n is not in this direction. This normal force is not in this direction. It is upward. And the force here is also upward. All right? All right, guys? So you can indicate an assumed direction for your net normal force or net force. And then whatever is your value, whatever is your sign, will lead you to the correct direction of these forces. Question.